Remember the last time you took an elevator? You pressed a button and effortlessly glided up several floors. Now imagine that elevator taking you not to another floor but to space. That's the incredible idea behind a lunar elevator. A lunar elevator is basically a cable stretching from the moon's surface to a point in space. This cable acts like a railway track, allowing specially designed vehicles to climb up and down. Sounds like science fiction? It did for a long time. But here's the kicker. While a space elevator from Earth is still a huge technological hurdle, building one on the moon is actually within our reach. It's all thanks to the moon's weaker gravity and lack of a pesky atmosphere to mess things up. So, buckle up, space enthusiasts. We're about to take a deep dive into the fascinating world of lunar elevators and explore how they could revolutionize space travel as we know it. You might be wondering, why build an elevator on the moon when we could just launch rockets? Well, rockets are expensive, for one. It's like taking a taxi every time you need groceries. A lunar elevator, once built, would be a much cheaper way to transport people and cargo to the moon. But here's the main difference. Earth's gravity is a real drag, literally. To build a space elevator from Earth, we'd need a material stronger than anything known to man. We're talking about materials that can withstand forces strong enough to rip apart most things we know. The moon, on the other hand, is much more accommodating. Its gravity is about 6 times weaker than Earth's. This means we can use existing super strong materials like Kevlar or even specially designed plastics to build our lunar elevator. Think of it as building a skyscraper versus a 2-story house. So, while an Earth-based space elevator remains a dream for now, a lunar elevator is a much more achievable goal with our current technology. The concept of space elevators has fascinated scientists and engineers for decades. It all began with Konstantin Tsiolkovsky, a Russian scientist, who first proposed the idea in 1895. Tsiolkovsky envisioned a tower reaching from the Earth's surface into space, inspired by the Eiffel Tower. Fast forward to the 1960s, the space race era, when the idea gained more traction. Science fiction author Arthur C. Clarke popularized the concept in his 1979 novel, The Fountains of Paradise. Technological advancements in materials science, particularly the development of carbon nanotubes, have brought the idea closer to reality. Carbon nanotubes are incredibly strong and lightweight, making them ideal for constructing the tether of a space elevator. In recent years, organizations like the International Space Elevator Consortium, ISEC, have been actively researching and promoting the development of space elevators. Various projects and proposals have emerged, each aiming to overcome the immense engineering challenges involved. The goal is to create a structure that can transport cargo and humans from Earth to geostationary orbit and beyond. The journey of space elevators is a testament to human ingenuity and the relentless pursuit of pushing the boundaries of space exploration. As we continue to innovate, the dream of building a space elevator moves closer to becoming a reality. Okay, so we've decided to build a lunar elevator. The next big question is, where do we put it? We can't just anchor it anywhere. We need a location that offers stability and makes our elevator as efficient as possible. Enter the Lagrange points. These are special points in space where the gravitational forces of the Earth and Moon balance each other out. Think of it as a gravitational sweet spot. For our lunar elevator, we have 2 prime candidates, Lagrange point 1, L1, and Lagrange point 2, L2. L1 sits between the Earth and the Moon, while L2 is on the far side of the Moon. Both locations have their pros and cons. L1 is closer to Earth, which makes communication easier. But L2 offers a clearer view of the cosmos, which is great for telescopes and other scientific instruments. The choice of location depends on what we want to achieve with our lunar elevator. But one thing's for sure, parking our elevator at a Lagrange point is the key to its stability and success. Now let's talk building materials. You can't just use ordinary steel cables to build an elevator to the moon. We need something incredibly strong, lightweight, and able to withstand the harsh conditions of space. Remember how I said the moon's gravity makes things easier? It allows us to use materials that already exist, like a super strong synthetic fiber called Kevlar. You might know Kevlar from bulletproof vests, but it's also strong enough to support a lunar elevator. Another contender is something called M5 fiber. This material is even lighter than Kevlar and boasts incredible strength. Imagine a ribbon so thin it's almost invisible, yet strong enough to lift tons of cargo. That's the magic of M5 fiber. Of course, we'll need to protect our elevator cable from micrometeoroids and radiation. but with the right materials and some clever engineering, a lunar elevator is well within the realm of possibility. Section 5. Design time, picture a ribbon to the moon. So, what would this lunar elevator actually look like? Picture a giant ribbon stretching from the moon's surface to a counterweight in space, anchored at a Lagrange point. The ribbon itself would be our super strong cable, likely made of Kevlar or M5 fiber. And why a ribbon and not a cable? Well, a flat ribbon distributes the stress more evenly, making it less likely to snap. As for the lunar surface, we'd need a sturdy base to anchor the elevator. This base would house the machinery for the elevator cars and provide a platform for loading and unloading cargo. At the other end, a large counterweight, perhaps an asteroid captured from space, would provide the necessary tension to keep the ribbon taut. Think of it as a giant anchor, keeping our elevator from falling back to the moon. This ribbon-like design, while simple in concept, is incredibly strong and efficient for a structure spanning hundreds of thousands of kilometers. Section 6. Climbing to the cosmos. A ride on the lunar elevator. Now for the fun part, the ride. How would we actually travel up and down this lunar elevator? Imagine stepping into a vehicle attached to the ribbon cable. This vehicle, our elevator car, would then climb up the cable using a system of rollers or magnetic levitation. Since there's no air resistance in space, the car could accelerate to incredible speeds, making the trip to the moon much faster than a traditional rocket launch. Plus, no more bone-jarring takeoffs and landings. Powering our elevator car could be as simple as using solar panels or beaming energy wirelessly from a base station on the moon. And since the moon's gravity weakens as you go higher, less and less energy is needed to keep the car moving. The view from the elevator car would be breathtaking. Imagine gazing down at the lunar surface shrinking below as you ascend towards the stars. It would be the ultimate space sightseeing experience. Section 8. Lunar Elevator, your one-stop shop for space resources. Now let's talk about the exciting possibilities a lunar elevator unlocks. Imagine the moon as a giant hardware store for space exploration. It's chock full of valuable resources like helium-3, a potential fuel for fusion reactors, rare Earth elements, and even water ice. But getting these resources back to Earth has always been a logistical nightmare. That's where our lunar elevator swoops in to save the day. With a lunar elevator, we could transport mined resources from the moon's surface to a point in space where they could be processed or sent back to Earth much more efficiently and cheaply than using rockets. Think of it as a cosmic conveyor belt, constantly delivering resources from the moon to fuel our growing presence in space. It's the key to unlocking the moon's economic and scientific potential. Section 9. To infinity and beyond. Launching missions from the moon. A lunar elevator wouldn't just be for transporting cargo, it could also become a launch pad for missions to Mars and beyond. Here's why. Launching a spacecraft from the moon is much easier than from Earth because of, you guessed it, that weaker lunar gravity. With a lunar elevator, we could assemble spacecraft in orbit around the moon, using resources mined from the lunar surface. These spacecraft could then be launched from the elevator's counterweight, giving them a significant head start on their journey into deep space. This would drastically reduce the cost and complexity of deep space missions, allowing us to explore the solar system like never before. The moon could become our stepping stone to the stars, all thanks to the power of the lunar elevator. Section 10. The future is up. Lunar elevators and the expansion of humanity. The development of a lunar elevator would be a game changer for humanity's future in space. It would open up a new era of affordable and accessible space travel, transforming the moon from a distant celestial body into an extension of our world. Imagine lunar cities, scientific outposts, and even space tourism becoming commonplace. A lunar elevator could make all of this possible, paving the way for a permanent human presence on the moon and beyond. The challenges are still significant, but the potential rewards are even greater. The lunar elevator is not just a technological marvel, it's a symbol of humanity's ambition to reach for the stars and unlock the secrets of the universe. Section 11. Conclusion. A giant leap for humankind, one elevator ride at a time. The concept of a lunar elevator may seem like something straight out of science fiction. Still, it represents a tangible and achievable step towards a future where humanity becomes a true spacefaring civilization. While challenges remain in terms of engineering, materials science, and funding, the fundamental principles are sound. With continued research and development, a lunar elevator could become a reality within our lifetimes. The implications are staggering. A lunar elevator would revolutionize space travel, making it more affordable and accessible to everyone. It would unlock the moon's vast resources, fueling our expansion into the solar system and beyond. And it would serve as a powerful symbol of human ingenuity and our relentless pursuit of knowledge and exploration. So the next time you step into an elevator, take a moment to imagine the possibilities. Perhaps one day, instead of just going up a few floors, you'll be taking a ride to the moon and beyond.